Welcome back, guys. In this lecture, we will start doing some examples. It is divided into 5 parts. In the first part, we will make a small example on arrays. And then in the second part, we'll talk about the difference between length and size. On the third part, we will talk about array addressing. In the fourth part, we will do some modifications on matrices. And in the last part, we'll talk about some built-in functions inside matrices. So let's start by the first example. I'm gonna first say clear all CLC. And I will define X as an array going from 0 to 3. You know that the colon operator will give me an array starting from 0 ending by 3, and here it is incremented by 1 since I'm not defining the increment, so it is by default 1. And remember, guys, that the colon operator will give me always a row vector unless you will be modifying it using the transpose to make it as a column vector. So this is X, let's say, and I need to find the sign of X. Sign is defined inside the library of Matlab as sin. So this is the symbol of sign. So if I do sign of X and then if I define Y as sign of X, Y will be an array of the same size of X where the elements of Y are the sign of the elements of X. So I will not put semicolon to see these elements, and you can see that this is Y. Now you will be somehow surprised that these are the values of the sign of X. Yes, because in fact sign will take the angle in radians and not in degrees. Alright, so this is the sign of X, and let's define that as the cosine of X. So likewise, Z will be an array of the same size of X having the elements equal to the cosine of the elements of X. So this is Z. Can I do Y plus Z? What do you think? Can I do the sum of sine of X and cosine X here? Yes, I can do Y plus Z because they have the same size. So Y plus Z will give me basically an answer, and this answer is valid with no errors. Now what if I need to prove using MATLAB that cosine squared plus sine squared is equal to 1? So how to do this? Basically, in order to do this, or if I need to do this, I mean that I need to make the cosine squared plus sine squared of each element of Y and Z, because Y is the sine and Z is the cosine. Now, what if I do this? Z squared plus Y squared, so small z, is it small z? Z squared plus Y squared. What do you think, guys? Is this giving me 1? Or is this giving me 1, 1, 1, 1, the same size of Z, Y? Or if this giving me an error, what do you think? This should give me an error because in fact I cannot do Z squared and as well as Y squared. I cannot do Z squared because in fact Z is not a square matrix to be multiplied by itself. I cannot do the product of Z with the Z because they do not have the same internal dimensions. Basically, Z has a dimension of 1 times 4, and Z has also the dimensions of 1 times 4. So I cannot do the multiplication of Z with Z. Basically, I cannot do the power of any matrix unless this matrix is a square, because if it is a square, then the internal dimensions will be the same. So basically, guys, I cannot do this. This will give me an error. Inputs must be scalar and square matrix. To compute element Y's power, use power dot power. So here, MATLAB is recommending to use a dot. What is a dot? Basically, guys, dot is used if I need to do an element by element operation. So if you use dot before the star, you're doing an element by element multiplication. If you're using dot before the power, you're doing an element by element power. If you use a dot before the slash, you're doing an element by element division. There's no need to use dot before the plus or minus, before sum or subtraction, because in fact sum and subtraction are done element by element. But I know that the product is not done element by element for matrices. It is another way to do the products of matrices where internal dimensions should be the same. Now, if you're using dot, this means that you are telling MATLAB that I need to do an element by element multiplication, and same goes for the power and the division. So this means, guys, that what should I do is to always you put the dot before the operator. So this dot here and this dot here, and what do you think the answer will be? The answer, guys, will be 1, but as an array of the same size of z and y. So 4 ones. This is for the first example, and this is for the use of dot. Now in the second part, I will clear all my variables, clear my command window. In this part, we'll talk about the difference between length and size. And for that, guys, I'm gonna define an array and a matrix. So first of all, I will define an array A, let's say, as 1, 4, 10. And I'm going to define A, so let's find out what is A here, as small a, and I know that A is a row vector, so I'm defining big A as this small a, so I'm putting this row vector as the first row of A, of big A, and the second row will be A plus 2. Can I do this? Yes, of course, because I can do the sum with any scalar, alright? So I'm not gonna put any semicolon here to see this A explicitly. So this is A. So basically, guys, the second row is the first row plus 2, so 1 plus 2, 3, 4 plus 2, 6, 10 plus 2, 12. Now, I'm going to start with the array, and I'm going to find the size of A. So what do you think the size of A? As we said before, the size of A will start by the number of rows, and then the number of columns, so the size of A here is 1, 3. And what is the size of big A? The size of big A is, of course, 2, 3. Now, what is a length? Let's find the length of small a. The answer here is 3. What does this mean? This means that the length for an array is the number of elements. So I know that small a has only 3 elements, 1, 4, 10. Then this means that the length of an array will give me the number of elements. However, what if I find the length of big A? If length is giving me the number of elements, then big A has 6 elements. This means that the length of big A will be 6. However, the answer here is 3. So what is the length? Basically, guys, the length will give me the maximum between the size elements. So the size of big A is 2, 3. The maximum between them is a 3. Then this means that the length of big A is a 3. If I go back to the array, any array has, if it is a row vector or even a column vector, has one of these 2 elements as 1, because it is either a column vector or a row vector. And the second element should be greater or equal to 1. This second element is basically the number of elements of A. And that's why the length of an array is the number of elements of this array, which is also the maximum between the size of this array, because one of these 2 will be 1. Alright? So this means, guys, that the length is the maximum between the elements of the size. If it is an array, this maximum will be basically the number of elements of this array. If it is a matrix, no, it is either the row number or the column numbers, depending which is the maximum between them. Now this is for the length and for the size. And don't forget, guys, the size will give me a row vector. So here, size of A is a row vector. So I can do, for example, size of A plus 2. So it is a row vector, all right, as any other defined row vectors.